All right. Yeah, it just worked. Good afternoon, Disobey. I would say great to be here, but I'm not so sure because this is a tough place for us, I think.
Yeah, a bit nervous.
Yeah, but for the next 50 minutes or so, we are going to talk about the need for network visibility in the age of modern EDR.
Yeah.
Right. That's why we are here. Hopefully, we can get something said.
So, a bit of background. We wanted to come and talk to our clients at GovTrack, where the people we know, a little bit of things we care about, so networking and...
Yeah, and as you maybe see, we thought we were going to be in some kind of moldy basement, like 10 people in the audience, and I don't know what happened, but here we are at the GovTrack, so we try to make it.
So, a bit of a disclaimer. We're going to go quite fast, use jargon, simplify things, because we have to show that demos run in time and stuff like that. We show our test environment, so not a production or client data or anything like that. And we don't want to glorify or bash any tool or vendor. So we say what we use, but we don't want to make the thing about the tools.
Yeah, and this is really important since we are using MDE as EDR solution and Zscaler as a secure web gateway. We are not to promote or bash anyone, but because we want to do demos, we have to use some real products.
So about us, my name is Ville Vainikka. I'm cybersecurity architect at Valtteri. I do networking security solutions. There's a lot of acronyms there, all of them and a bit more. I've been 12 years in the government, 6 different roles from everything, basically. Also, again, I'm really into the technical deep dive things, and well, you can read it yourself.
Yeah. And my name is Henri, and I'm a Ville's colleague from Valtteri, and I also work as a cybersecurity architect. I've been working for the Finnish government for the last 14 years or so, doing IT stuff, cybersecurity stuff. I've been around for a while, and I'm that guy who is weirdly into log files. You all know that guy. Okay, so a couple of words about Valtteri. So for those who don't know what we do, we are basically government's in-house IT service provider. The computer people for the common services like the networking and data centers and all of that stuff. So we have roughly about 80,000 end users, so we have big environment, and with over 100 client organizations, them being different agencies and ministries in the government. Yeah. And we have a bit over 1,400 employees scattered all over Finland. So, yeah, I don't know if we are big, but we have people.
Yeah, and we've been investing heavily on security lately. So we have about 100 people doing security, and it's growing all the time for the past 3 years or so.
Yeah, when we started 3 years ago with Ville, we had like 50 people doing security. So that has been quite a growth, and that has enabled us to do lots of cool things, I think.
Yeah, and we want to show a little bit of the cool things we're doing.
Yeah.
So about our cybersecurity services, we do a lot of stuff. So we got 18 different services we provide for different type of cybersecurity needs. We got 50 different technology stacks. And one of the cool things we have been able to do is that we do market research and not just like listen to the PowerPoints, but actually do proof of value and actually go into the deep dive and see what is actually under the hood before we buy anything. So we understand what we're trying to buy, and one of the reasons we're talking about it here. And the EPV, or the EDR and the SASE solutions are 2 of those products we are going to talk today.
Yeah, sure. And as you can see, we have lots of different technology in our stack. We do cloud technology, we do purely on-prem technology in air-gapped environments, and that causes different tooling for sure.
Yeah, and again, when we started 3 years ago, we had like normal antivirus stuff, logs from there, firewall logs, proxy logs, and nowadays we are doing EDR, Zero Trust Network Access, SASE, and SSL decryption. Yeah. So a lot has changed for us, and again, our SOC is slightly less depressed now because some of the tools actually work.
And also the SOC exists nowadays. Before we were using outsourced SOC, but nowadays we are having like 15 people doing our 24/7 SOC. I thought they were cheering for that, but yeah, okay.
Okay, so about visibility and our tools that we're going to use to achieve it. So we're talking here about endpoints, and usually the tools are either like control or visibility. And we're talking about the visibility side here. Control is really important, but that would be another talk of its own. And again, we're talking about endpoint side, so data centers and stuff like that. It works quite the same, but it's still different, and again, would be a different talk. And again, the visibility is really important because many times when things happen, we don't know what we're looking for or what we should be controlling, because if we would know everything, we would control everything and everything would be secure, and it's not. So visibility makes us able to do threat hunting, for example, investigating and doing actual finding out what actually happened.
Yeah, for sure.
And why network visibility is important is because almost every system on its own is secure. Nobody does in secure systems by default, or some do, but most of them don't. And communicating with other system is the thing that introduces the threat. And there's also like memory and file visibility, but we're not going to be talking about them that much here, but the network side and why it is important.
Yeah, so really basic things here that we are going to talk about.
Yeah. So quickly about the tools. So like I said, we use Microsoft EDR, we use Zscaler SASE solution, or Secure Web Gateway, and we use CM solution from Microsoft in this demo.
Yeah, but remember, these are not important. There are lots of other tools to do this.
If you know what you're looking at. So, okay, about the actual, to understand why the network visibility is important, you have to compare to EDR, you have to understand what the EDR actually does. So, in simple terms, what the EDR sees is what the operating system sees. So basically API calls that some program makes when it's using some of the operating system's resources. Again, 3 types of visibility here. Memory, so process info, the actual program you're seeing, but only outside from it. So you can see process PID spawning account, so who is starting it, process handles its calling, child, parents, resource usage, stuff like that, what like flags it was used to start it. But usually nothing inside the actual program, and this is quite important. You could actually do that technically, but you can take a snapshot of the memory and go inside it, but it's not really cost effective because you would have to actually map every program, and every time it gets updated, it breaks down.
Yes, and obviously we are simplifying stuff here. So obviously, if you know how the EDRs actually work, they are a bit more complicated, but I think this is the,
we have to actually be able to explain it here. So again, there's this file side of visibility, so what files were used by what process, and network side of things for the EDR, it means that everything that's usually unencrypted. So you can see the IP addresses, TCP ports, UDP ports, DNS domains from the DNS queries, HTTP connect request if you're using a proxy, TLS certificates, how much data was transmitted and stuff like that, but not anything inside it because it cannot see inside your browser. And again, EDR is usually really great on Windows machines, but on any other operating system, Linux, macOS, Android, iPhone, not that good. And this same applies to other visibility tools usually. So, for example, you can get full network like a next generation firewall working on Windows, and usually for others it's just a proxy working.
And this is not to say they are getting better all the time on the Linux boxes and Mac OS boxes. So, but yeah, Windows is still the crown jewel for the EDR vendors because that's where the end users are.
Yeah, and most of the time.
Yeah.
And especially for us.
Yeah.
So, just to drive the point home, what does an EDR see? So, when you go to some site, here it's the Disobey site, and there's an IP address and a port. So, what you're going to go and I'm going to fast demo it. Here.
So this is the scary part where we do live demos and jump around between the desktops. So let's see how we can make it.
So what I'm gonna just do is refresh the site. Basically, it did it. And what I have here is do-it-yourself EDR, basically on PowerShell. So what I'm getting here, I can list all of the processes. I can list all of the network connections, a lot of them. And on their own, it's just a dump. Too much information. But when I combine it here, just doing this, running. I'm just combining the process information with the network information that is available in the operating system, and I can see where I'm connecting, which operating system is connecting, and now my Chrome exe did like 6 connections to disobey.fi. And basically, this is what the EDR could see because it's using basically the same APIs.
So your humble brag about how you built EDR with like 10 lines of PowerShell.
Yeah.
I like that.
Yeah, and again, it's not an EDR, but it's the same amount of visibility. So just to understand what it can see.
Yep.
And here we also had the secure WebGate on. So I'm tunneling traffic to an SSL decryption engine. So we can actually see what it's been doing. I'm going to show it here. First, this is our SIEM solution that I was talking about earlier. So this is what MDE sees basically on the network stack. So it's the same stuff. Again, there's more information and it's been enriched. I'm not showing those because that's not important. That's not the basic information. It's just enriched. Everything goes back to source IP, destination IP, TCP port, and then you can get the initiation process account name. So basically, what's the user account? Again, the same stuff I showed with the PowerShell. And then I'll do it from the secure web gateway side. And it's a bit different. Again, it's like quite accurate strings, so usually you would get more information, but here you can see the big difference. So basically, the one connection that you can see from the EDR side, which is the TCP connection, here I can see the application layer, so layer 7, and all of the actual HTTP application requests, all the files that were downloaded. All of the folders were used, and for example, stuff like request headers. So what was probably the browser being used or the application being used and the request method. So get, post, options and stuff like that. So you get a lot of more information from the SSL decryption side.
Yeah, and we think this is something you need when you are hunting for threats or trying to detect something weird going on in your environment. So that just the connection info by itself, it's quite limited. It's important, and the EDR provides lots of great stuff, but also you would maybe like to have the actual request info.
Yeah. So here was just in case the network didn't work, the same stuff. So I'm gonna go over them quickly. So basically, EDR and as a solution, or any SSL decryption engine that can do the same, they share some properties. So you get IP, port, domain, user, device, and operating system information. EDR can see the starting process information, which the SASE solution usually cannot get.
And this is big.
This is huge. This is absolutely huge because you can do like change who started whatever and stuff like that. But you can take a guess at headers. So if it's a normal user using it, so then headers can be valid. But if it's like a threat actors, something, it's going to say that it's just the newest Chrome version.
Yeah, and they will
so
not
you
be
cannot
valid.
trust that.
Yeah.
And again, like EDR sees TCP sessions, and the SASE can see HTTP application level requests. So the agent headers, TLS info, more metadata than because you can see it on every HTTP connection. The file names for downloads is quite big, especially when you can start getting file hashes. So you can automatically do hash searches and do links from if you get IOCs from somewhere else. And also one big thing is on the Windows machines you can get the like a next generation firewall log. So you can get level 4 like really accurate IP, TCP information and even CASP information. So which is like cloud application logs, which can be really like what happened with Teams or OneDrive or whatever, a file dump. You can see way more stuff. And one really big thing that you can get here is passive DNS. So you're going to be able to record every DNS request, its payload, and the response. So you get a full passive DNS that you can combine. And this is something that usually you cannot get with an EDR. So you can detect the DNS tunnels.
Yeah, we don't have any examples on that. So but it's a big.
But this is the basic idea. Again, we also wanted to bring out the mobile side of things, but here we scrapped the demo because mobile logging is slow. So it can take up to 2 hours to get the logs to the SIEM, so showing it would be kind of pointless. Basically, here we have an MDE that is logging Android device when it's doing network events, and what is actually logging, it's local IP.
Yeah.
So there's happening something, but what it doesn't log.
So this isn't very useful for you when you are trying to find something happening from the mobile device towards the network. So
what you could do with this is maybe go to look at Wi-Fi access point or something like that, and from there you could get some flows or something like that. But on its own, it's really, really small. But when you do this, combine this with a secure web gateway, the same requests that were there, you get actually the same information. So HTTP like request methods, the actual files, the headers, and all of the good stuff that you can get from the network side. Because this is a really big thing, because the mobile devices, they are running sandboxes, and you cannot do like so invasive monitoring basically on the processes and stuff like that. It just won't tell you. But if you don't do it on the mobile device, but you do it on the line, you can get way more information. So basically this is the same on the Windows endpoints as it is on the Android devices on the gateway side. So again, the same things. The EDRs usually aren't really EDRs on mobile devices.
Yeah, that's right. So, okay, for our next use case, detecting and somewhat preventing also C2s using network visibility. And we are going to go with the real classic here. So, tricking the user to run some malicious stuff, and then we are going to steal their files through C2 channel over the internet and over the HTTPS, because that's one thing we would like to show you, that the TLS interception might be vital when you are looking for bad things to happen. Yeah, and we are showcasing this from the following assumptions. So the user is running up-to-date Windows 11 box. We are not trying to cheat here. The user is just normal user without admin rights. And big for us, there is no app locker policy in place. Unfortunately, I think this is still the case in many of the organizations. So yeah, we are letting the user run anything he or she can download from the internet, and that makes it easier for us.
App locker is strong, but it's a pain in the ass to actually implement. So that's why it's the case. Yeah,
and on our victim machines, we also have a MDE running and Defender for antivirus without any exceptions. So this can create demo effects for us, but there is more to enjoy for you if our demo fails horribly. So yeah, and the final one, it's a big one. The user can be tricked to download and run something from the internet, but let me tell you, when you have 80,000 end users, this is not going to be the problem. So there's always...
somebody's going to click something.
Yeah. And here you can see our big attack plan. So it all starts with a phishing mail. It always starts with a phishing mail. And that contains link to a site, which then contains link to download the exe file that acts as a dropper. That's our fake client. And when the user runs the fake client, it downloads the payload from the internet and then extracts the payload and places exe service to user's local app data, creates a shortcut to user startup for persistence, and then starts the service, which is actually the info stealer and the C2 connection to our server. And then we get the files, maybe. And yeah, because I think it might be illegal to do a presentation without involving ChatGPT in one way or another. We decided to jump on the hype train also. So our phishing is ChatGPT themed.
Yeah, because it's hot.
Yeah. And we were so lazy that we even went on and made the AI to write the phishing mail for us. And I think the future is here. That's great. Okay, so let's go. Just a second. This and this. Okay, on the left you can see our first victim machine, and just wanted to show you that we are not trying to cheat. The Defender is on. There is also the Sense and EDR process on, but yeah, you can see it soon. The Secure Web Gateway is off for the first demo, and on the right you can see our C2 server. We are actually using this Trevor C2 slightly modified version, but it's a common C2. I think many of you know it, and it works by sending GET requests from the client to the server. So that is what we are running here. So as said, all starts with a phishing mail, and hopefully it will work. So this is the phishing mail. This is not so important. And then there is a site which user goes to. Looks legit, right? You would click everything in here, I know. Yeah, download now and try. No registration or installing.
Why won't you?
Yeah, sounds good. So we are going to download the client, and now we are going to see the first stuff. So this is the mark of the web thing. I think many of you know this, and the way that the actors, the threat actors used to get by this was to stuff the EXEs inside the ISOs and VHDs, but I think Microsoft fixed that like in last November or December. So as I'm aware, there is no easy way to get around the mark of the web thing, but I'm sure that someone in the audience will prove me wrong in like next 1 minute or so. But yeah, no worries, because the user really wants the ChatGPT to write his mails or something, so we will run it anyway. Okay, something happens. Let's connect. Because I'm the user, I just want to connect it. I don't know where, but there is a button for it. Okay, so yeah, something happened. But the important part, the user just goes on with his day or something. But the important part is on the right side, we got the C2 connection, and I hope it will work. Okay, so here it is. We can say interact. We can say who am I. We can say host name, whatever. So we are basically just giving the commands to the victim machine, and there is no alerts, none whatsoever, and there should be no alerts in the MDE console also. Sorry, the site went down for a second. Let's see. Oh, devices. And there is our devices, this and this. And if all is good, there is no incident here. Just a second, and no incident here. So the EDR does not pick it. Well, it does pick a lot of things, but it doesn't alert. So
yeah, it's just logging now.
Yeah. So I think on the usual cases, there would be nothing done by SOCs. So let's. Okay. So we can say list home because we want to steal their files, right? And there we can see, I don't know if you can see it, it's quite small, but this is basically the contents of the user's home folder. So a couple of interesting files, you know, some KeePass file, I think. Let's download. Get this there, and another file also. Let's download that one. So stealing files, fun, right?
And easy.
Yeah, and there is the files. Also the other one, let's say cat. Okay, that's the text from here. Nailed it.
Yeah.
Yeah. So that was our first demo. That was our first victim machine. Just MDE and antivirus.
Yeah.
There.
No network controls.
Yeah. So next up, I will just say exit one time. And we go to another box to demo what would happen when the secure web gateway would be there by default. Yeah, so with the categorization stuff and so on. Actually, I will close this because it is running as an admin. And same thing, we are going to start with the phishing mail. We are going to click the same link. And this is the first difference. The user would get one more, just one more warning. Are you sure you want to do this because the site is categorized by MISC or unknown?
Yeah,
I don't know.
It's not been seen it before.
Yeah, but as we said, user really wants to do this. So we don't have a policy right now that would block the user to download the exe file. I think we should do it, but right now we are letting the users to download the exes from the unknown sites in this demo at least. So
it's a bit difficult because customers want to download stuff. So
yeah, your fault. Your fault if you're our customers. Okay, so we get the client, and this should be, yeah. So this is for the prevention that we were talking about. So actually, mind explaining us why we are getting this? Can you?
Yeah. So basically, we are not blocking it. Actually, what we're doing it's the script basically running on CLI, and it's trying to take the HTTP connection, and we're generating that web page that says, "Are you sure? Please click OK." And the program doesn't know how to click OK, so it doesn't go through.
Yes. So by an accident, we just prevented C2 connection from ever happening.
Not by accident, by design, but
by accident, I say. Okay, but yeah, many of you also know that the categorization is just one problem for the attacker. They can get around it.
Definitely, and our solution, it's not to control everything 100%. That is maybe for some other environment. Our job is just to make it safe enough. So basically, we're playing a numbers game. So we got a lot of users, and it is okay if something bad happens every now and then, if most of them get to do their work.
Yeah, so it is all about raising the bar. That's a cliche, but it is. It really is all about raising the bar.
About making it harder. So we don't get 100 cases, we get one case. Or we don't get 1,000 cases, we get 100 cases.
Yeah, so for now we are going to simulate the scenario where the threat actor has been, in some way, has the categorized page that can be used in this case. So I'm going to download different client that communicates with a different address. And let's open it, and hopefully it will connect. Something happened. Yay, the connection. So this is just to say that the secure web gateway is nowhere perfect, because we can get the C2 connection working even with that.
So what happened here is just that categorization, it's a safe domain. So you use some domain that was in some other use, for example, and you bought it off, and now you're just using it to go through it. It's not 100%, but again, it's making stuff harder. One more step.
List home. And this is very basic stuff. We have absolutely no EDR or antivirus evasions in place in our bad binaries. It's just like 300 lines of C# code and using the basic binary, the basic libraries.
Again, it's obfuscated in Finnish, so that's why it doesn't get caught up by...
Yeah, since we didn't want to get caught so easily, we made lots of Finnish function names and variables. So yeah, that was the biggest encryption or obfuscating there. But yeah, we could download the files. This is not so important anymore, but I'm going to do it anyway just to showcase. Download. And it works. So the secure web gateway helped us to prevent with this setup, but it was no perfect.
Again, the point is not to show absolute control, but how to detect it, which is the next step.
And still there should be no alerts, but we can see lots of stuff in the timeline for the EDR solution. So if I write ChatGPT, so as you can see, it sees a lot. This is good stuff for threat hunting, but it is not enough for the MDE to raise an alert that your SOC would be looking at. So this would have to be done by manually threat hunting.
Or getting an IOC from somewhere else that you should be taking a look at this site or this type of EXE or a hash or something like that.
Yeah, and at least we would like to know if there was these kinds of info stealer running in our users' computers. So it would be a lot to have alerts, right?
It would be nice.
Yeah, so, but yeah, it is working. We are not cheating here. And then for the promised detection part of it, so couple of quick ways how could one detect this C2, like Trevor C2. So first one would be from the network visibility, using the network visibility. So first one would be detect base 64 encoding from the GET requests heading towards non-whitelisted or some non-categorized pages. So actually I have just run it, and the logs are generated before the event because there's a slight delay, and it is not, the query is not the important part here. I just wanted to show that we can get it caught because this is the C2 connection, and I also wanted to show that this is going to create some false positives. Absolutely, because
some others use base 64 for legit reasons.
Yeah, lots of others use base 64, and it is not perfect. It is not something you would alert the SOC tier 1, but it is definitely something you can use in the threat hunting.
Exactly, it's not definitive, it's something to actually get on working.
And another one using the network visibility would be to find connections that have like a high amount of GET requests with static received and sent bytes heading to the same destination from the same host, because the way Trevor C2 and a couple of other C2s also work is when they ask for the information from the server, if there is like just wait, don't do anything, the request is always symmetrical. It's always same kind.
Or almost same. Again, they have to poll it.
Yeah.
Even though if they do like intervals that is random, they still have to poll it.
Yeah, and I think in this case we left the C2 running for a couple of hours, and it created
a lot of requests.
Yeah, a lot of requests, over 1,000. Sorry. And the last one would be to chase constant communication between some host machine and destination host using HTTPS, like find sources and destinations that have been communicating at least once per 10 minutes for 1 hour. And this has been quite useful for, at least in my experience. There are going to be false positives also in here, but this would be the starting points that you would take and then go to the EDR logs and find out what's going on. You can do it another way around, and you will do it a lot of times another way around, but without network visibility, it is, I say, you are not getting all of it that you could.
Yeah.
So let's see. Yeah,
we have time.
Yeah, we have time. So I think I'm done with the demos here.
Just jump on the slides.
And let's jump on the desktop number 1. Go ahead. Oh, yeah. Sorry.
Still you.
Yeah. And I guess you're all thinking that I am wrong and maybe some bit dumb. But what about X, Y, and Z? And yeah, this was just one C2 profile. But in many cases, some kind of encoding is employed, and that's something you can look for if you have the URIs.
Yeah. So again, nothing is definitive. Again, it's just stuff you can use to do more threat hunting, better threat hunting. And once you get a lot of different ways of finding that the same domain is bad, then you probably have a case. And then you maybe should go and take a look at other logs, like the EDR logs or whatever other you may have available. Yeah,
and many C2s also, they don't use GET requests, but they use POST requests, and they would be also easy to spot if you know it is a POST request. If you can do this from the just regular proxy logs if you do TLS interception, but TLS interception is important in this case, right?
Yeah.
And yeah, detecting C2s using network traffic, even with the TLS interception, is not a magic bullet. But it is a great addition to have network visibility, as Ville just explained. And with this, it is possible to create more context and hunt threats in your CMs. And just last thing, don't forget about the control part. That this was not the point of our presentation today, but really, does your normal users need to download EXEs and ISOs and VHDs from the untrusted sites?
Or other scripts and stuff like that.
Yeah,
that can be run or hiding some stuff.
I hope not. So, summary about the C2 detection and prevention. First, deploy AppLocker. You don't want your users to run random shit in your workstations, and this can be done, and this should be done. Even in the big environments like ours, it can be done. It is a pain in the ass, like Ville said, but
it takes a long time. And
yeah, and still there's ways to get around the application control. There will be remote code execution vulnerabilities, and there will be bypasses using lol bins.
File-ish stuff. And
yeah, but all, again, raising the bar, and actually we think the EDRs are getting very good at preventing these limited amount of techniques. The EDRs and antivirus are not perfect when you let everything in and let everything to run. And yeah, if the attacker still gets around the application control and the EDR, the network control and visibility is usually your last line of defense. So at least we think it should be there. And what we are after, we are after application control plus modern EDR plus network control and visibility and logs from all of them. And with that way, we are going to maximize the prevention and detection capabilities. Yeah, lots of great write-ups and so on, but yeah.
So another use case. So detecting adversary-in-the-middle, so ADM, it's really nice acronym. So basically, again, here we are not trying to prevent it. We are trying to detect something because you cannot get it all. Once you get a lot of, the user base is big, something is going to go through. We don't know what it is, but it's going to go through. So the idea is here that doing an ATM, the adversary can get the login password information and a session cookie that works without multi-factor authentication and actually can get them with the multi-factor authentication. And the idea is here that once you get an IOC, how do you know that how many users actually did the stupid thing and went through with it and gave the cookie and the passwords out? Because not everybody that visits a site goes through with the logging process. So idea again here is that stuff happened. You can see that 100 people clicked the link, but how many were actually compromised?
Yeah, and this is very big for the SOC guys. I think if we were to ask anyone who is doing SOC work, they would agree that it is important to really know who fell in and who didn't. And as last weeks we had like a massive amounts of secure email phishing campaigns going on. So it is relevant actually.
It is relevant. So here what we're trying to show you is that we have an endpoint, then we have the decryption in the line, and then we have another decryption that is evil kinks, and then we have an Azure AD where we're logging into. So a lot of SSL decryption. And just a second.
And the last demo. So far everything has been going just great, no pressure.
So here I have a link that is using a domain Vaitori.com. So with the big L or big I, it looks a bit like Valtteri. And then hoping. And here I can see that somebody landed on my landing page and it's trying to log in. And then I'm looking at my passwords. Oh, it failed, so I have to log in. and because we have MFA everywhere, it's asking me to confirm it. But because I'm logging in and I know that I'm logging in, I'm going to click it.
Yeah, you're expecting to get an MFA and you will approve it.
And here's critical part. So now I went through with it, but do I want to get more login prompts? I don't. So I'm going to click this and save a cookie to my machine. And this happened. So basically, it failed and it went the login again, probably not working. But once I show here, oops. Too many else. I'm going to make that big.
So what are we looking at?
What we're looking at is my credentials. So because we were doing the decryption, that's my username, that's my password, and this is my KMSI cookie. If I copy-paste this to another browser, I can log in straight, as long as the conditional access policy is not blocking it, which is usually never, especially when I'm coming from Finland. So basically, I can bypass the MFA to any AD or Azure AD service, enterprise application or whatnot that this user would have.
Yeah, so all that the attacker has to do is to get the user tricked to that site and doing the login.
Link, it looks semi-legit, and then it's like rotating it through these phases, and you're getting all of this information.
And again, we are seeing every week that a lot of worse stuff goes through from the users. So this is same time scary and will create a lot more work for us in the future also.
And here is the detection part. So basically, we had the SSL decryption on there. So we are getting the actual login information, all of the requests, all of the files, all the request types. And we can see that it went through. It checked that does it have a KMSI on? It didn't. So it went into the login phase, and then it went through the whole of the login phase, and these logs are not in the correct order because the timestamping is a bit delayed, but it went through the end auth. So basically, I went through the whole logging process, and because I know I have MFA, that just happened. So here, if we get an information that there was this domain that was bad, we're looking at it, we're getting the actual requests, we can see that this user went through the whole thing.
Yeah, so this is the smoking gun. We are sure that this account is compromised and we can start the needed actions. Yeah, you don't have to guess. Yeah.
And here is the same again if the demo wasn't working. So basically, what we are going to see is the initial URI. So we're going to get the actual IOC that we can, for example, give to somebody else. That there is this kind of bad domain and this URI that is doing this type of spoofing. And we can show beyond the door that the MFA went through. So there's going to be the cookie also. And now we know who the SOC has to bother with actual changing credentials and going through a security training again. So, in summary, it's really short.
Yeah.
If you have to pick, get an EDR. It's way better, it's way wholesome, you get way more stuff. Okay, it's not perfect, but if you can, you should get both because it adds value.
Yeah, I think this is no-brainer. If you can only pick one, I would pick EDR 100 times out of 100.
Maybe 90, but...
Yeah, but I think you need also the network visibility, the XDR stuff that some vendors might be saying this time it is. So that was our last slide, 45 minutes. We didn't lie so much about the time. And finally, just wanted to advertise. We also have open positions as everyone. So join the good fight, look our positions up from the valtiolepisto.fi or come talk with us about anything, about stuff in this presentation or about working for the government. It's fun and rewarding. And
the pay is great.
Yeah, Juho said it already. Yeah, and pays well. Okay.
Thank you.
So with that, thank you guys and girls. Thank you.